Hi, Dr. Tortopati. It's Matt. Just coming on here to explain my work for question 2. So to start off for question 3, I started off by finding out my slope, which I used my initials M, number 13, plus P, 16, equals 29, divided by that by 1,000, got 0.029. And then I set up my flow diagram. My fluid planes were in the corners. So my section 1 was my first fluid plane. Then the middle section was my main fluid plane. So yeah, for B, that's my diagram. So for B, section 1, I started off by finding my area of my triangle for my first section using the given equations. And then using the Manning's equation, I plugged everything in to solve for my flow for my section 1. Got 93.04 meters cubed per second. And then, for that one too, it says the longitudinal slope of the fluid plane is half of the main channel. So I divided my slope by 2 and used that. I'm not sure if that's correct, but... And then for section 2, I went through the same process, found my area of my main channel, perimeter with the governing equations, and then again plugged it into the Manning's equation and got a value of 276.16 meters cubed per second. And then section 3 is the same exact, should be the same exact flow as section 1. And then to find the total flow rate at a depth of 6 meters, I added up all my flows from each section and got 462.24 meters cubed per second. So that was for question 3. Question 4, so this one, I wrote down all my givens, and then using the specific energy equation, y plus q squared over 2ga, I plugged everything in and got a value of 5.55. I was a little tripped up on this question. And then I know from there, in order to find whether it's a subcritical or supercritical flow, you just solve for your Froude number, and I plugged my flow and my top width, my T, which I solved using that equation, B plus M YC times 2, got 9. So I plugged all that in and got a value of 1.27, and then knowing that since my Froude number is 1.27 and it's greater than 1, that means it is a subcritical flow. I don't really understand about the alternate depth, so I just left that blank. Then finally for question 5, started off, had to find the critical depth and normal depth of this channel, and then the overall classification. So to start off with the normal depth, I started off with a Manning equation again, and first I had to solve for my area and perimeter of my rectangle and the hydraulic radius. So I plugged everything in, and we were solving for y sub n, which is the normal depth. After plugging everything and using solver, I got a value of 3.012 meters. And then from there, I went to solve for my critical depth, and using that equation, again, finding, top width and area, plugged everything in, still solving for y sub e, which came from my area, plugged that in the solver, and got a value of 1.21. I got 1.21 using solver, but I also got 3.99 using my calculator, but I think I was messing something up on there, so I stuck with 1.21. And then knowing my y sub n was then greater than my normal depth was greater than my critical depth, so that means I had a mild slope. And then using the given y gauge station, y equals 2, that was in between my y sub n and y sub c, so that means it was in zone 2, which is negative, so it's decreasing. So that would give my classification as an M2 profile. And then for B, compute the slope using the depth of 2.2 meters. I then used the Manning's equation again and solved again for my areas, perimeters, and hydraulic radius given the new y value, so 2.2 meters. And then solve for my new slope, and then plug that in the solver, got a value 0.00234. And then from there, I had to solve for my Froude number and plug that into the equation, got 2.19. And then from there, plug that into dy over dx. So I had my original slope minus my new slope solved for over 1 minus Froude number squared, got 0.00126, and then plug that into dy over dx. And then so my y2 would be my new height minus y1, which is my original height. And then so we're starting at 0 for the distance, so we're solving for the whole length, so that's x2. So then solving that, set that equal to my dy over dx, and got a distance of 177.62 meters. And then for C, the next method was the direct step method. So we broke this up into sections for my average slope 1. So we'll start with the y, 1 equals 2 meters. Solve for my area, perimeter, and then my velocity, and plug that into the new equation. It was the average friction. I'm sorry. The governing equation to find the new slope. So I plugged all those values in, got 0.00306 for my slope 1. Did the same process, but for y2, got a value of 0.00234. And then I used the average friction slope method and plugged all those values in, got 0.0027. And then to find my change in length, I used that equation that we went over in week 11's class for problem 4. So the change in length, plug that in, and got a length of 94.66 meters, which is different than I got for part B, but I think that just comes from, I explained in part D, I'd prefer to use the first method just because you're using an average slope in part C, so I don't think that's as accurate, I'm guessing. So yeah, that's my my work for my exam 2. If you have any questions, let me know. Yeah, I saw you at Pancheros yesterday. I thought that was funny, but don't think I was trying to be weird coming up to you. I thought it was funny that I ran into you the day before the exam, so I just wanted to ask you a quick question. So, all right. Thank you, Dr. Toilet Patty. Yeah, bye.